As Heinz just said, and as that slide said, I was indeed an atheist and an evolutionist, and I was an atheist because I was an evolutionist. I understood that science said quite clearly that there is no need for God, so why would you believe in one? And it wasn't after being confronted with evidence against my atheism and evolutionism and trying to disprove that for almost a year that I was confronted with the fact that the evidence is actually against atheism, against evolutionism, and for the Bible specifically. And I like to mention that when I speak for a couple of reasons. Number one, we're often told in this debate that Christians are creationists because we have to be, because the Bible says that. That because we're pre-committed with faith in this book, that puts blinders on us, and if we could take the blinders off and see all the evidence in the world for the millions of years and Darwinian processes and so on, then surely we would recognize that that side is true. I'm one of many for whom the opposite is true, though. I became a creationist first because of the evidence, and that then opened the door to becoming a Christian. And I'm not alone in the creation movement. There's many others who followed a similar path. But that's why I do what I do, to share some of the information that's out here on these type of subjects and show that this isn't, our faith is not blind. Science is on our side. Having said that, of course, science is a very large field. What questions do we talk about in a meeting like this? Well, there's very broad subjects and then there's very narrow ones. And I have the privilege tonight of speaking on a more narrow topic than most, I suppose. I get to take a deep dive into one specific issue, which is that of distant starlight. Does it disprove biblical creation? And the question here is fairly straightforward. It's one of the most common questions asked in this debate, is that how can we see light from these distant objects? I mean, light leaves a star in a distant galaxy and travels through space, and eventually, after traveling vast distances of space, will then arrive at Earth where we can perceive it, whether through a telescope or our unaided eye or whatever. And we're told that it must take long periods of time for light to travel these distances. Well, how would you make such a calculation? How would you know whether or not that's true? Well, this is a fairly straightforward idea. I mean, we do similar things in our daily lives every day. Let's say you needed to drive 120 miles to get from home to wherever. If you could drive at 60 miles an hour, how long would it take you to make that trip? 2 hours. It's straightforward, right? What calculation are you performing to reach that conclusion? Well, time is the distance divided by the speed. In this case, 120 miles divided by 60 miles per hour equals 2 hours. We're going to use this same approach and apply it to distant starlight and see how long actually is needed for starlight to transit over these long distances. Now, something that we'll be mentioning frequently here tonight is a light year. If you're not familiar with that term, it's confusing because it sounds like it's a measure of time, because it's got the word year in it. It's actually a measure of distance. So a light year is the distance that light can travel in 1 year. And it's a very long distance, as you can imagine. I mean, light travels at 186,000 miles per second. So over the course of a year, light can travel a long distance, as you can imagine. Nevertheless, we can see objects that are quite far away. Not only close by stars, but even within our Milky Way galaxy, there's objects that are significantly far from us. For example, this is the Bubble Nebula here in our own Milky Way galaxy. Estimates of distance vary, but it's between 7,000 to 11,000 light years from us. Thus, applying the calculation that we just talked about, let's say it's 10,000 light years away to make the math easier. If this object is 10,000 light years away, and light travels at 1 light year every year, then it's straightforward to say that would require 10,000 years for the light to get here. How can we therefore see it if the universe is only 6,000 years old, as the Bible would imply? And we'll talk about that in a moment. And this is just an object within our own Milky Way galaxy. There are galaxies outside of ours. For example, the Andromeda galaxy is 2.5 million light years away. So it would seem that light would need 2.5 million years to get here. And modern instruments have enabled us to view things even further in space. We now have adaptive optics in some observatories that use lasers to correct for atmospheric turbulence, thus allowing us to get even better images than we had before. And of course, we also have space telescopes. Never before in man's history have we been able to see so deeply into space and to see so well. And as we've used these instruments, we are seeing things farther and farther away. We're seeing galaxies over 13 billion light years away. A billion is 1,000 million. So 13,200 million light years away, thus apparently needing 13.2 billion years to get here. And latest observations are pushing the boundaries even farther out to well above 13 billion light years at this point. So again, this raises the question, how can we see objects that apparently would need over 13 billion years for the light to get here if the universe is only thousands of years old? It seems like a straightforward issue, and also a very serious problem for us as Bible-believing Christians. In fact, as I mentioned, this is one of the most commonly asked questions about creation, and the atheists, of course, believe this is very important as well. There's an entire page on this atheist wiki dedicated to it. They think that this alone is a complete showstopper for us. They don't need any other arguments, according to some. This alone shows that the Bible, or the biblical worldview, is not correct. For our purposes tonight, I'm going to abbreviate this issue as LTT, standing for light travel time. How do we account for long periods of time for light to travel in a young universe? Well, why does this even matter to us in the first place? It matters because the Bible talks indirectly, not directly, but indirectly, about how long ago the creation occurred. Adam was created roughly 6,000 years ago. Now, the Bible doesn't give a date for him, but it does give genealogies subsequent to him. And when you add up all the numbers, you arrive at Adam being created roughly 6,000 years ago. The Bible also says that in the beginning, God created the heavens and the earth, familiar verse to us, I would hope. God created man in his own image. And when he saw everything that he had made, behold, it was very good, and the evening and morning were the sixth day. So Adam was created on the sixth day after creation itself, after the creation of everything, I should say. And then subsequently to then, 6,000 years more or less have passed. Now, some people say, well, maybe that 6 days of creation in the beginning were long, indefinite periods of time. Maybe it's not literal days. Maybe we can fit the billions of years in there somehow. Well, that's not an option for us either. In Mark chapter 10, Jesus was having a conversation, and his opponents that he was arguing with said, Moses permitted a man to write a certificate of dismissal and to divorce her. But Jesus said to them, he wrote this commandment for you because of your hard hearts. But, speaking of Adam and Eve now, at the beginning of creation, God made them male and female. Jesus confirmed Adam and Eve were created right at the beginning of everything, not billions of years after the creation. And I brought this up to some people, and someone actually said, well, maybe Jesus didn't know when God created Adam and Eve. And I said, well, that's an even bigger problem than the creation issue, because Jesus, of course, is the creator, right? All things were made by him, and without him was not anything made that was made. So if the creation is roughly 6,000 years old, how then do we account for this LTT issue? Is it really a fatal challenge to biblical creation? Well, of course, there's no surprise here. I wouldn't be here speaking to you tonight if that were the case. In talking to a skeptic about this, and they bring this point up, you can say, wait a minute, not so fast. This is not a challenge only for me. This is also a challenge for you, because this challenge actually applies to everybody, not only biblical Christians. What do I mean by that? Well, let's talk for a moment about the Big Bang model. This topic tonight is not about the Big Bang specifically. I do have other presentations just on that issue, and the Big Bang has lots of problems. But one of the problems that I will talk about is the CMB, the cosmic microwave background. When we look out into space, there's microwave radiation coming to Earth from all directions in space. And if you imagine us being the inside of a sphere, where the inside of the sphere is all the heavens, open up that sphere and unwrap it, and you would get this oval shape, right? That's what this map is. So this is a map of the sky and the radiation coming to us from all points. The different colors represent small variations in temperature. So why is this important? Because this radiation is supposedly the afterglow of the Big Bang. Roughly 400,000 years or so, a little bit less than that, after the Big Bang was supposed to have occurred, this cosmic microwave background was formed, and we are viewing it today, almost 14 billion years later. Now, the Big Bang model says that early in the universe's history, there had not yet been enough time for light to travel all the way across the entire cosmos. And again, I'm speaking in the context of the Big Bang model here. This is very early after the Big Bang, and so light couldn't travel very far at all. Furthermore, the Big Bang model says that the universe started out with variations in temperature at different places. Therefore, if it started out with variations in temperature, and if there wasn't enough time for light to travel very far before this CMB was formed, then there wasn't enough time for heat to travel either, so the unevenness of heat couldn't have been evened out. I know I'm using the word even a lot there. Point is, the heat energy could not have distributed itself evenly throughout the cosmos by the time the CMB formed. This is what the Big Bang model says. That means that the Big Bang model predicts we should still see temperature variations in the CMB today. The problem for the Big Bang model is that we don't. The entire universe, the entire CMB, is roughly the same temperature. I say roughly, I mean it's to within 1,000th of a degree. Very, very tiny variations. This does not match what the Big Bang model predicts. This actually is sufficient all by itself to disprove the Big Bang model. This is called the horizon problem, by the way, if you wanted to look this up. Light has apparently traveled across the entire universe because the entire universe has arrived at the same temperature. That means heat has been able to flow from the hotter areas to the colder areas to bring everything to the same temperature. But in the Big Bang model, there hasn't been enough time to do that. Not back then when the CMB was formed, and it also couldn't have happened since then, by the way, either. Point is, the Big Bang model predicts variations in temperature because there hasn't been enough time for heat to travel across to even everything out, but that's not what we see. Now, of course, secular cosmologists are aware of this. They say they have a solution called cosmic inflation. That has a whole basket of problems all by itself. It's the idea that the universe somehow started to inflate at many times the speed of light early in the universe's history, and then decided to stop doing that afterwards for whatever, and has gone on since then. It's a very contrived proposal. Even some of its early architects of that theory have abandoned it since because it's gotten so contrived. Nevertheless, you will be told it's true because we know the Big Bang happened, and that's the only way to get around the horizon problem. So while resisting the temptation to talk more about inflation and all of its problems, I'll just point out the Big Bang model has a light travel time problem of its own. It too has to explain how heat and therefore light could have traveled across the entire cosmos even when the model doesn't provide enough time for that to have happened. So the broader point here is that LTT is not just an issue for biblical Christians, it's an issue for everyone. We're on an even playing field here. The skeptic doesn't get to point his finger at us and say, haha, gotcha, because he's got the same problem. Having said that, I'm now going to talk about why it's not really a problem for us. We aren't on the defensive here. There are actually multiple possible solutions, and that will be the point of my presentation here this evening. The LTT challenge, as I'm going to refer to it, is based actually on 7 assumptions. It seems like a straightforward problem, doesn't it? We see faraway objects. I mean, that's only 4 words. That sort of implies there's been time for the light to get here. But as simple and straightforward as the problem seems, it's actually quite subtle, and there's 7 assumptions built into it. All 7 of those assumptions must be true, or the challenge itself falls apart. It's invalidated. Now, I'm going to talk about all 7. It turns out one of them appears to be reasonable. All the rest can be questioned, and at least one of them is actually false. That means the LTT challenge itself is not valid. So what do I mean when I say there's assumptions? Well, let's go back to our equation here, time equals distance over speed. Let's talk about the speed for a moment. This calculation assumes that the speed of light hasn't changed, right? What if the speed of light has decreased through history? What if it used to be faster in the past and is now slower than it used to be? That would mean what? It would mean light could travel farther back then than it could for the same amount of time today, right? So you see, this idea, by questioning this assumption of constant light speed through time, would therefore make this challenge go away. And indeed, this idea was seriously looked at a number of years ago. There was a lot of interest in it in creation circles. Upon subsequent examination, this idea didn't really hold up, and so most creationists today would not question that assumption anymore. I wanted to mention it first for a couple reasons. Number one, a lot of people have heard of this idea because, as I said, it was quite popular. Number two, you see how this is a crucial assumption. The LTT challenge requires that the speed of light hasn't changed, otherwise the challenge itself falls apart, doesn't it? Now, as I said, apparently this is a true assumption, but this is the only one of the 7 that we can say that of. I'm not saying they're all false, but I'm saying they're not necessarily all of them are true, but at least one of them is false, as we'll see in a moment. So this will be the structure for the rest of my time here this evening. We're going to go through all 7 assumptions. We just did number 1. You see that was pretty simple, right? So now we're going to do the remaining 6 and see how they withstand scrutiny, if indeed they are able to do so. So let's move on to the second assumption. Back to our equation. It's a simple equation. What other things can we challenge within it? Well, let's talk about the speed again. In order to do this calculation, you need to know the speed of light, don't you? Now, you can look up the speed of light in Wikipedia or physics book or whatever, and you'll be told it's 186,000 miles per second. That's actually not the speed that goes into this equation, though. The speed that you get when you look it up in a reference somewhere is the two-way speed of light. The speed of light that's measured when it goes out and is reflected back to you, and you use the same clock to measure when it left and when it arrived again. But that's not what's at play in this equation, is it? This equation is how long light took to travel in one direction only, from out there to here. What is the one-way speed of light? We don't know. We've never measured it, not because it's too difficult, but because it's impossible. It is physically impossible to measure the one-way speed of light. If you look at all the various approaches that have been tried, you first have to assume that you know what it is and assume a number for it before you can do the experiment and get a calculation that tells you what the number is. And it turns out the number that you assume at the beginning is always the number you get from the experiment. This is a famous problem in physics. It's actually been around for quite some time. There's a whole Wikipedia page dedicated to it. And it may not make sense to you. It's like, well, why would it be different in one when it only travels in one direction? It's not that it really, quote unquote, travels at a different speed in one direction only. It's that when you do a calculation using this number, you have to choose the number first before you can do the calculation. And it turns out, regardless of the numbers you choose to use, as long as you set up your experiment and your calculation so that the numbers always average out to the known two-way speed, then it works. There's actually entire YouTube videos dedicated to this. And for examples, more practical example. There's a spacecraft that left Earth and is going somewhere, and we want to talk to the astronauts. Now radio waves travel at the speed of light. So we can assume that the radio wave travels at the same speed in both directions, and then we know that when our message is transmitted, and when they receive it, and when they answer back to us, and so on. And we also can figure out like where to aim the signal so it'll arrive to where they are when they get it. But you can also make the assumption that light and radio waves travel infinitely fast to them, and then slower on the way back so that you get the same average, the known number. And it turns out everything works out exactly the same. You will still be able to communicate with the astronauts. And they'll still be able to communicate with you if they make different assumptions. As long as you're consistent with the assumptions you make, it always works. Now, I know this is probably getting confusing, but my point is the one-way speed of light is not a known number that you can measure. It's physically impossible to measure it. You have to assume what it is before you can do any experiments. And assuming different numbers always works as long as you're consistent in how you apply them. So to make this calculation using the one-way speed of light is impossible. This equation assumes that the speed of light in one direction only is both absolute and known, and it is not. It is neither absolute nor is it known. So you can't do the calculation because it's impossible to do it. It requires a number that we don't know and cannot know because it's impossible to know. So back to our assumptions. This was assumption number 2, that the one-way speed of light is absolute and then we know what it is. You need to know that number to do the calculation. And we don't know it because we can't know it. It's impossible to know it. Now we could actually stop the presentation right here because this alone is enough to invalidate the LTT challenge. But having said that, even if we assume that we do know the one-way speed, there's other problems with this challenge as well. Let's go back to our equation. Time equals distance over speed. What about the distance? Can that be challenged? Sometimes people wonder, is it possible that these objects aren't actually as far away from us as they are claimed to be? There is some uncertainty in the measurements in many cases, but you're only talking about a few percentage points for the most part. These objects are indeed vast distances away from us, certainly a lot farther than 6,000 light years in most cases. So yes, the objects are far away, but this calculation assumes that the light had to travel across the entire distance to get here from there. What if that weren't true? What if instead light beams were created as full light beams? And you've probably heard this idea because it's been popular in Christian circles for a while. And the argument goes something like this: if the heavens are to declare the glory of God, shouldn't they do so right away? When Adam woke up on day 6, on that night, could he see stars in the sky? And the Bible doesn't say so, but it seems reasonable to say that he did. So the light had to be there for him. So why wouldn't the Lord create a fully functional, mature creation so that it could serve his purposes? Sometimes people call this the appearance of age idea, but people who hold to this generally prefer calling it mature creation because it's a better description and includes the description of why God would do it that way in the first place. And the adherence to this model, let me back up a minute. As I discuss these assumptions tonight, I forgot to mention this earlier, I'm going to present different models for you. I have my own ideas on this subject, but I'm not endorsing any particular one tonight. I'm trying to keep my ideas private. My goal is not to sell you on one particular solution to this issue. My goal is to show you all of the different approaches that people are taking. And by people, I mean all of these models that I'm showing you, there's been a credentialed scientist in the creation movement advocating it. By credentialed, I mean a PhD in astrophysics, physics, or astronomy. So I'm not trying to convince you of any one particular solution. I'm trying to show you of all the different approaches that are being discussed and some of the pros and cons of them so you can make up your own mind. So for this particular model, those who adhere to it, again, prefer to call it mature creation, which I think is a good description. And they correctly point out that mature creation is necessary for at least some of God's creation. It's certainly necessary for the earth. I mean, when Adam woke up on day 6, was there a pile of nuts and seeds next to him that he had to go plant? No, he woke up with functional, fully mature fruit trees and other plants that he could consume and eat from. So in that sense, the plants were created mature, and the water in the river the water in the river was flowing already. He didn't have to wait for it to start flowing out of the mountains upstream and so on. So the earth at least had to be created mature. Why not stars and starlight as well? Having said that, not everyone in the creation movement likes this idea, and they have some fairly strong objections. One of the strongest is that this would make God a deceiver. It would make God deceptive. Why do they say that? Well, as an example, this is a supernova called supernova 1987A. It was observed occurring in 1987, as you might gather from the name. We saw a star blow up in a violent supernova explosion. And since 1987, we've been observing the remnant expand and change over time. And so there's actually some interesting physics going on here that we're learning from. Point is, we saw the star, and then we saw the star blow up. And not only did we see it blow up, we also got particles accompanying the image of the explosion when it arrived here. Now, this star is roughly 168,000 light years away from us. If God created all the starlight as full beams in place as part of the mature creation idea, what was created in the case of this object? Well, there would be a beam of light going between us and it, and this beam of light would be 168,000 light years long, right? Because that's how far away this object is. The first 6,000 light years, more or less, of that beam contained the image of a star, because we saw the star. As time went on, the Earth was basically consuming this light beam as it was flowing toward us, And no extra charge for the Hollywood quality of graphics here, by the way. So you see, consuming the light beam, and again, we're still consuming that image of the star. Not that anyone on Earth had telescopes at the time to perceive that, but nevertheless, that's what was happening. And then in 1987, the image of the star changed to an image of a supernova. Problem with this, according to people who don't like this idea, is that this idea means the star never existed. We were watching a movie of it for 6,000 years, but the light beam itself is 168,000 light years long. So the first 6,000 years worth of the beam that we consumed had a picture of a star that never existed. Furthermore, the supernova didn't happen either. In fact, we're not going to see anything real for another 162,000 years, because it'll take us that long to consume the rest of the light beam that hasn't arrived here yet. What's at the other end? We have no idea, and we're not going to find out for a long time. So people who don't like mature creation say this would make God a deceiver because all these things we see in the heavens never actually existed. You see the problem there? Now, the counter objection to that from people who like this idea is that, well, God's not a deceiver if he told us what's going on. Like, was Adam deceived by the mature fruit trees? Even it looked 4 or 5 years old when he woke up next to one? No, because God said, I made this on day 3. In similar way, God told us he created the cosmos 6,000 years ago, so we shouldn't be deceived by false assumptions about how light beams and such are working. Furthermore, saying that mature creation applies only to Earth actually doesn't go far enough. There's actually a precedent for applying it to stars as well, because there's at least one star where mature creation apparently would need to apply. Our sun produces light deep inside of itself, and it turns out that the light that it produces from nuclear fusion takes a while to work its way out to the surface. Now, once it reaches the surface, it shoots to us through space at the speed of light and reaches here in a little over 8 minutes. But it actually takes thousands of years, if we understand the physics correctly, for the light, once it's produced, to work its way up to the surface and then shoot to us quickly. So could Adam see the sun when he woke up on day 6? I think so. But sunlight produced by the sun wouldn't have been available to any human for thousands of years. Possibly not even yet, because some estimates say it takes up to 10,000 years for light to work its way out and come to us through space. So you understand the difference, right? Once it reaches the surface, it shoots to us at the speed of light. But for various reasons, the light gets absorbed, re-emitted on the way out, and it takes up to 10,000 years for the sunlight to reach the surface. So in a sense, all the sunlight that we're still consuming today had to be initially created by God farther out from the center of the sun. And the sun's actual sunlight that it's actually making, we haven't seen any of that yet. So mature creation would seem to be necessary for at least our sun. Why not the other stars too? So again, I'm not endorsing or denying this particular model. I'm showing you the pros and cons so you can understand the discussion that's going on. But it is clear, hopefully though, that this is the third necessary assumption in the LTT challenge, that the universe was not created mature. Because if it were created mature, then the challenge is invalidated. So what other assumptions can we find in the LTT challenge? Well, let's go back to our equation, and let's talk about the distance again. And a similar question, did the light actually travel that distance in the way that we understand? What do I mean by that? Well, a few years back, a Bible-believing astronomer, Dr. Danny Faulkner, noticed something interesting in the book of Genesis. In the creation account, it says, God said, "Let the earth bring forth grass, the herb-yielding seed and the fruit tree." And the earth brought forth grass and herb-yielding seed after his kind, and the tree, etc. Many of us tend to think of these creation events as ex nihilo, from nothing. God said, "Let there be plants," and poof, there was plants. Is that what the text actually says, though? No. God commanded the earth, "Bring forth plants," and the earth brought them forth. The Hebrew word here for brought forth is dasha. So Dr. Faulkner started wondering, it sounds like the earth brought forth plants in a normal way, like the earth is doing today, but God commanded it to happen very quickly so that it all happened on day 3. So apparently plant production was a normal process that was just accelerated for God's purposes during creation week. And he started wondering, what if that happened on day 4 also? What if God commanded the stars, bring forth starlight? And lo, they did. This means that the starlight we see was actually produced by stars, so God is not deceiving us. The supernova actually happened, and the star that we saw before the supernova actually existed. But God used supernatural processes to quickly bring that light to us all on day 4. Now, some people don't like this idea. A skeptic, of course, wouldn't like this idea because it's explicitly miraculous. This is not trying to use physics to explain how this could have happened. This is just saying God performed a miracle and brought the light here all on day 4. And yes, indeed, this is a miraculous process. But as Christians, we shouldn't be ashamed of that. Even when talking to a skeptic, you can point out, yes, this is a miraculous process. Well, so is the universe. Any secular cosmology, if you think about it, actually includes miracles as well, whether or not the skeptics want to admit that, because the Big Bang model, for example, violates laws of physics early on in the model, and if you're violating laws of physics, you're kind of by definition performing a miracle, right? So in a sense, everyone believes in miracles, whether you believe God brought the universe into existence or whether you believe it created itself. There's miracles in both models. The difference is miracles are consistent with our viewpoint, but inconsistent with theirs. So the fact that it's miraculous, and a miraculous explanation, shouldn't bother us. One thing, though, that some people have pointed out is that even if this idea were correct, there's no way to actually test it, because there's no scientific experiment you can run to verify that a miracle happened if you don't understand what that process was. So although this may be a correct explanation, it perhaps isn't as useful as a scientific model because there's no scientific prediction you can make and test. So those are the pros and cons of what's being called Dasha cosmology. And you see how that's an important assumption in the LTT challenge, the assumption that light has always traveled through space across that entire distance as it does today. So that's 4 assumptions. What else can we glean from this challenge? Back to our equation, let's talk about the speed again. What if the speed is variable? What if the speed is not constant? We talked about this before, and we said that the idea that it's changed through time apparently isn't a valid thing to be investigating because it seems to be a reasonable assumption. What if, however, it's variable not through time, but through space? What if the speed of light varies according to your location? Let's think about this. Where have we ever measured the speed of light? Where have all of our measurements been done from? Earth, from within our solar system. And our solar system is within the Milky Way galaxy. What is the speed of light outside of the galaxy? We have no idea. We've never been there. And we have no hope of ever getting there, for that matter. Why is this an interesting thing to be thinking about? Because relativity tells us that space-time, slow my speaking here, space-time behaves essentially as a fabric. Mass distorts the fabric of space-time, and we'll talk more about this here in a moment. We know that this actually affects the path of light beams. Light will be bent around massive objects in space. This is called gravitational lensing. Einstein's relativity predicted this, and it's subsequently been observed, and there's actually lots of examples of this. If you look it up, you can find lots of pictures. There are examples where there's a galaxy here, and then from our point of view, there's another galaxy behind this one that we can't see, but we can still get partial images from it because the light from this one is going out and being bent by the gravity of the closer one and then being focused onto the Earth. Gravitational lensing, if you've heard of that. So if gravity can affect light's path, could it also affect its speed? Well, if gravity slowed down light, that means light would travel more quickly in places where it's not as affected by gravity. like deep space, for example, in between galaxies, where there's no objects to produce gravity to slow the light down. Is the speed of light the same out there in deep intergalactic space? Or is it faster? We don't know. But it is a possibility that's been gaining attention in the creation movement lately. And in a sense, we're actually latecomers to the game because secular cosmologists have been talking about this for quite some time. Now, their motives are different than ours. They're actually trying to solve some problems in the Big Bang model with this idea. But my point is, this isn't some fringe idea that creationists came up with. There are quite a few scientists looking into the idea that maybe light travels more quickly through deep space where it's not as affected by gravity. You can see then how that would speed up its path toward us, its travel time toward us, and shorten the time it needs to get here, right? This is called VSOL, variable speed of light. So that's questioning the other assumption in our list here, the assumption that light speed is constant across space. If that weren't true, and it may not be true, as I said, it's being investigated, then the LTT challenge doesn't work. What else can we glean? Looks like I'm missing a bullet point on my slide here. Oops. What else can we glean from this? Well, we've talked about distance and we've talked about speed. Can we question time in this equation? Where can we go with that? Well, when we tend to think about the creation account, we tend to think it happened from inner to outer. I'll show what I mean by that in just a moment. What if that's not true? What if it's actually outer to inner? So here's what I mean. We tend to think that the Earth was created on the inside of the cosmos, in a sense, at least from our perspective. You know, we're here, and then the Lord created all the stuff out there. So working from inwards to outwards. What if he actually went the opposite sequence? What if instead he created an outer shell, if you will, of galaxies, and then moving his focus inwards toward the center where the Earth will be, and moving his focus to the speed of light, he created another shell and another shell. And so the light from the outermost ones is moving inward as he's creating new ones along the path, adding more light to it, until day 4 of creation week, when the Earth gets created and all the starlight arrives here. Until day 4 of creation week, when the Earth had already been here for several days. But on day 4, all that starlight from all the galaxies arrives here from all directions simultaneously. And the night sky went from being empty to suddenly, abruptly being full. Because on the 4th day, the sky was empty, and then suddenly everything appeared. So from an Earth perspective, from an observer on Earth, that's when creation would have happened, the 4th day. Because you look at an empty sky, and then suddenly, boom, it's full of galaxies, stars, and everything else. Now, when we suggest this to someone, and Christians, of course, will often say, wait a minute, this implies the galaxies were created before the Earth, billions of years before. Because it took that long for to create everything on the way in, changing the focus, if you will, at the speed of light. Is this a good explanation, changing the focus? You understand what I'm saying? Create the outer shell and then inner shell, but doing that in sync with all the light that's starting to travel inward? This does indeed suggest, in a way, that the galaxies were created first, but only from a certain perspective. From the Earth's perspective, the Earth existed for a number of days, the sky was empty, nothing else existed, and then suddenly the sky was full. Nevertheless, people don't like, often, the idea that these other galaxies were created first, before the Earth, because they're thinking in terms of an absolute clock. Now, from an observer perspective, from an observer clock, if you will, everything was created on day 4. Everything in the sky, I mean. But people still tend to say, wait, but from an absolute overall perspective, the galaxies were first, and that doesn't really match Genesis. Everyone see the issue here? Well, we're applying our everyday thinking to the cosmos when we make that statement, or make that objection, I should say. And that's not necessarily a valid way to do it. Not absolutely, at least. So what do we mean by that? There's 2 ways of interpreting the things you experience in life. Okay? So here's a question. I know this is being recorded, and for people who are watching this in the room with me, are you experiencing this as a live event in real time? Or are you watching a recording of me? No, you're experiencing this as a live event, right? But are you really? Is the speed of sound infinite? Or does it take a small amount of time for my voice to travel from where I am to where you are? It takes a small amount of time, right? There's a delay. So are you thinking that you're really only watching kind of a recording of this a fraction of a second after it's all actually happening? No. You consider that you're experiencing this as it happens, right? Now, in real life, this doesn't matter because that little time delay is insignificant. On an astronomical scale, though, it does matter. You have to choose which way to interpret the events. If you see an eclipse of the sun, solar eclipse, when the moon travels in between us and the sun and blocks out the sun's disk. If you haven't seen one, by the way, make the effort. There's another one coming to the US here shortly. It's worth traveling to go see it. Because when it first fully covers the sun, that first moment of totality is breathtaking. But if you experience that, do you grumble and say, well, it looks kind of impressive, but it takes more than a second for the light to get here from the moon, so I'm watching this event in a 1 second time delay, and so I'm not really experiencing it? No, of course not. You enjoy it as you experience it, right? That's when you consider it as happening. If you get to see Venus transiting across the face of the sun, which happens very rarely, the next event is, I believe, the year 2117, when Venus travels in between us and the sun. That's Venus right there. Very rare event. You're very blessed to see it because it happens so infrequently. But if you do get to see it, do you grumble and complain because, well, it took over 2 minutes of the light to get here. I'm not really getting to see it. This is like a recording. No. As you experience it, that's when you consider it happening. For that, and we do this all the time in astronomy even. This supernova was named what? 1987A, because we experienced it, we observed it in the year 1987. Did we call it supernova 166,000 BC? Because that's when it really happened? No. We label it according to when we experienced it. So that same logic, saying that, well, the galaxy's being created first doesn't match Genesis, that's not a valid objection. Because if you were on Earth at that time, you would have seen an empty sky, nothing existed yet, and then suddenly on day 4, boom, there's a sky full of stars and galaxies. So that's when you consider creation of those objects to have happened. So I'm saying that there's no absolute sequence of time when it comes to the cosmos. You can choose to do it in several different ways. So the idea that galaxies were created out there on the way into Earth and all the light arriving here at the same time, I'm arguing that that does not violate the creation account in Genesis. If you're still unsure about this, and you may be, I mean, don't be embarrassed. A lot of people have to grapple with this. Ask me during Q&A, and we'll do a demonstration up here on stage to show you that on cosmic distance scales, our normal ideas about before and after no longer apply absolutely. So I won't take the time now to do it because I want to make sure people are interested in it. If not, I won't spend the time. For now, I'll just point out that that is another assumption built into this challenge, that we have to use an absolute sequence for ordering events in the cosmos, and that's not necessarily true. So that's 6 assumptions so far, and I said there were 7. What else can we possibly get out of this one simple equation? Well, one more thing we can do is, again, to question time. In a different way, though. We're going to talk about a phenomenon called time dilation, which sounds weird, but is actually a real thing in physics. Turns out that gravity affects time. Einstein's relativity predicted this, and then subsequently was verified by experiment over and over and over again. The stronger the gravitational field is, wherever you are, the slower time flows for you. And if that sounds like a weird concept, here's another way to put it. Every possible clock you could possibly build, whether it was based on mechanical gears or atomic processes or flowing water or whatever, every possible clock that's possible to build is going to operate more slowly when gravity is stronger. This is, as I mentioned, this has been verified by experiment. For example, some of the most accurate clocks we can build currently are atomic cesium clocks. There's several of them around the world. We have a couple here in the US. There's one in Boulder, Colorado, a mile or so above sea level. And there's one in Maryland, close to sea level, very close. The one at sea level ticks, atomic clock doesn't really tick, but the one at sea level ticks a little more slowly than the one in Boulder. Why is that? Because it's deeper into the Earth's gravitational field. The one in Boulder is higher, thus slightly less gravity, and thus slightly faster time there. Sounds weird, but it's true. In fact, some of our technology has to compensate for this in order to work. I'm showing you a GPS satellite here. The GPS system relies on accurate calibration of clocks between the device in your pocket and several satellites up there. Them being out in space means they are farther out of the Earth's gravitational field than we are down here with our phones. Turns out that time flows more quickly for the satellites than it does for us. And the GPS system has to compensate for this, otherwise the calculations wouldn't work. This is called gravitational time dilation, and it speeds up clocks on the GPS satellites relative to us by about 45 microseconds per day. The net, incidentally, is a little bit less than that because there's a second effect that counteracts some of it. But overall, GPS has to compensate for a difference in 38 microseconds per day between their clocks out in space and our clocks here in our pockets on our devices. So point is, gravity affects time. The more gravity there is, the slower time goes. Why are we talking about this? Because a few years ago, a Bible-believing physicist noticed that a number of places in the Bible, it says that God, the Lord, created the heavens and stretched them out. You probably have seen verses like this, right? There's more than one. And he started to wonder, what would that look like? Is this poetry? Or did God actually stretch something out during creation week? Well, if he stretched it out, then that means it started out in a smaller volume. So what would that imply? Well, if the volume of stuff in the early universe was small enough, that would place the universe inside of a black hole. And that has some interesting implications. Now, black holes are really mysterious objects. Gravity is so strong that even light can't escape, which is why they appear to be black, because you can't see it. No light comes directly to us from there. But we can see the effects that they have on their environment. A star that travels too close to a black hole will actually be ripped apart and form what's called an accretion disk. This is an artist's illustration here, but we do actually observe accretion disks at some places in the cosmos. This is M87, and there's actually, turns out, a monster black hole at the center of our own Milky Way galaxy. But among their other weird effects, not only can black holes rip things apart that get too close, they also, because of their gravity, have an effect on time. If you were unlucky enough to approach a black hole, from the perspective of someone outside observing this, time for you would slow down. Your clocks would run slower and slower until you reached the boundary of the black hole, at which point time would stop for you. So, back to our proposal from the physicist. He realized that if the universe was in a small enough volume to begin with, then it would be inside of a black hole, the boundary of which is represented here by the dotted line. Now, this is called the event horizon. It's not a physical thing. It's not a shell or something. It's just a distance. Within this distance from the center of the black hole, that's where all the black hole weirdness is going on. Now let's say the Lord stretched out the universe. And this takes a miracle, of course, because black holes don't expand. But the Lord being the Lord, he can do that if he wants to. So if he stretches out the heavens and starts to create things from the matter in the heavens, at this point, everything is still within the black hole. But as he keeps stretching, eventually some material moves outside of the event horizon, therefore outside the black hole, which causes the event horizon to shrink. So the black hole gets smaller. And here's where it gets interesting, because now some galaxies are outside the black hole while the rest, including our Milky Way galaxy, is still inside. And remember, we talked about gravity and time. Time is now flowing normally out here, whereas inside the black hole, it's still essentially stopped. The Lord continues stretching. More stuff moves outside the black hole. Black hole continues to shrink. Time is still passing out there. Time is still stopped inside. As the Lord continues stretching, eventually enough material moves out of the event horizon that the black hole dissipates. It goes away. And all the black hole weirdness stops happening. From this point onwards, time is flowing uniformly throughout the entire cosmos. Unless you're close to a massive object that it affects you slightly. But overall, time is now flowing normally. But what happened up to this point? Lots and lots of time happened out here, whereas nothing happened here where we are. So millions or even billions of years could pass in the far outer regions of the cosmos, giving enough time for light to travel to here from there, also giving time for other things to happen out there, like galaxy collisions and things that seem to need long periods of time. While on Earth, one day passed. This proposal is based, again, on gravitational time dilation. Dr. Humphreys, the physicist that whose idea we're talking about, has actually taken this model in other directions since this first one. His subsequent ideas are quite a bit more complicated, though, so rather than talk about those, I like talking about his first model because it illustrates the basic concept. Point is, depending on how the Lord distributed the matter, the stuff in the early universe, time will flow differently in different places. So you can see how that opens up all sorts of possibilities for modeling how starlight could travel, right? Because that is indeed the seventh assumption built into the LTT challenge, the assumption that time has always flowed uniformly throughout the cosmos. And depending on how the initial universe its mass was distributed, that's not necessarily true. So in our session, we've gone through all 7 of these assumptions. I pointed out that number 1 is probably correct. I don't have a problem with it personally. But all 7 have to be correct in order for the challenge itself to be valid. We know number 2 for sure is incorrect. And the others can be challenged as well. So when addressing distant starlight, does it actually disprove biblical creation? No, it doesn't. There's lots of possibilities here. And again, I'm not suggesting any one model is the best one. I have my favorite. But you can see how there's multiple possible approaches to this problem. As Gary Bates from Creation Ministries International likes to say, this is a great time to be a biblical creationist. Go back 20 years and people were saying mature creation was really the only option we had. Now there's, well, maybe longer than 20 years, a bit longer than that. But now there's almost too many options, right? Maybe the actual solution is something we haven't even considered yet. Or maybe it's a combination of several of them. My point is this is not a showstopper for us. Multiple possible approaches, and it's exciting and fascinating to discuss this. Having so many potential solutions is not a bad thing, it's a good thing. Because it allows us to contrast and compare, look at the advantages and disadvantages of each, and come up with the best possible solution. Which we can do because this is not a fatal challenge for us. The heavens declare the glory of God. And good science, true science that looks at the universe dispassionately and objectively, is always going to support that. We shouldn't be afraid of what science shows us because science is on our side.